Hello. This tutorial describes how to use the metadata functions of Zeddy to provide useful search facilities and to control how transactions get processed. The word metadata is used to describe information about data, so in this context it refers to information about the transaction Zeddy has processed. For a transaction like a purchase order, the metadata could include things like the order number, the order date, delivery location, and so on. Metadata serves two main purposes within Zeddy. The first is extracting information that could be useful in locating a transaction at some point in the future, and the other is controlling how a transaction gets processed. If we were to capture the order numbers from every order, ASN, and invoice that gets processed, then at some point in the future, you or one of your colleagues will be able to perform a search for a specific order and find all the transactions that relate to it. Metadata can also be useful when setting up actions within Zeddy. You might, for example, be asked to configure Zeddy so that it will email a copy of every Depot 14 order to the warehouse manager for that depot, in addition to sending it to the supplier. Metadata is extracted by running a mapping which generates an XML file in a specific format. The information it extracts is then recorded against the transaction. This is an example of the XML produced by one of these style sheets. The root tag is always metadata extract, and it can contain an update section, a metadata section, or both. If we look at the metadata section first, you'll see that it has a supplier code tag containing the value PF298. This will cause the metadata for the transaction to include a field called supplier code, which has a value of PF298. So the tag name will become the name of the metadata field, and its value will become the value of that field. You can call the metadata fields anything you like, but it's a good idea to be consistent. If you use the name order number when processing outbound orders, then it's a good idea to use order number when processing incoming ASNs and invoices, rather than ordnum, POnum, etc. That will make finding transactions in the future significantly easier. Sometimes it's useful to capture a list of values rather than a single value. In our case, the purchase order files we're processing could contain multiple orders, so we need to be able to capture all the order numbers and not just the first one. You can see an example of how this is done on the order number tag. This has a collection attribute which tells Zeddy that it contains a list of values rather than a single value. The value tags within the order number tag are then used to list out the order numbers that the file contains. Once this has been processed by Zeddy, the metadata for the transaction will look like this. Notice that the metadata also includes a field called number of transactions. This was generated automatically by Zeddy as a result of the split the file action that was used to generate the file in the first place. If you want to know more about split the file, there's a separate video called Splitting Files that discusses it. It's also worth noting that the metadata for a transaction is carried forward to any child transactions that get created from it. If our order XML were to be mapped to produce an Edifact order file, that new file would start off with all the same metadata as the XML file it came from. Now that's useful when running searches, because it allows the user to quickly locate the original XML as well as all the EDI files that were produced from it. Let's look at the update section now. Purpose of this is to allow the metadata extract to change some of the basic information about the file. One of the uses for this is to change the document type from whatever it was originally to something more meaningful. Imagine we were receiving XML invoice files from one of our suppliers, and that the root tag on those files is always going to be invoices. One of the tags within the invoice file indicates what type of invoice it contains. The possible options are normal invoice, pro forma invoice, credit note, and debit note. So it would be useful to change the document type from invoices to a more specific value like credit note and have it appear within Zeddy as such. This would then allow us to configure separate actions to handle normal invoice, pro forma invoice, credit note and debit note using whatever sequence of actions are appropriate to them. In our example, we're happy to leave the document type as it is, but it would be useful to reassign the transaction to the appropriate trading partner based on the supplier ID. In this way, instead of seeing this, we'd see this. Unlike the metadata section, the tag names within the update section are predefined, and these are the possibilities: condition code, direction, partner ID, and document type. Condition code can be one of the following values. Direction can be an uppercase I for inbound or an uppercase O for outbound. Partner ID must be a number that corresponds to an existing trading partner definition within ZE. There's a function called getPartnerByIdentity that can be really useful in determining this, but more on that in a bit. Document type can be any value you like, providing it's meaningful to the people who'll see it. We're now going to walk through an example of a metadata extract style sheet. It looks like this. The XSL output tag is used to say that we'll be producing an XML file. We've also defined an XSL key, which is used later when recording the delivery location IDs. The first statement after the XSL template is an XSL variable called partner. This uses the getPartnerByIdentity function to locate the trading partner definition for the current supplier. It works by looking at the identities assigned to each partner and finding the one that has a given supplier ID assigned to it. If a partner is found, then the style sheet can output the numeric partner ID for it using this expression. In the metadata section, the style sheet loops through the orders in the file and outputs a list of the order numbers it finds. It then does a similar thing for the delivery ID, this time using this rather nasty looking but useful expression to output just the distinct values. In our scenario, we know that the file it will be processing will contain only orders for a single supplier, so the expressions for supplier code and supplier name tags are very straightforward. Metadata also has a role to play when configuring ZE actions. Normally when you create an action, you specify the direction, trading partner, document type, and condition that it applies to. But in some situations this isn't specific enough, and to handle that we can use metadata criteria. To illustrate this, we're going to say that there's a requirement to send a copy of each order file generated on the 31st of March 2019 for Octagon supplies to a specific email address. Our metadata extract will have already created a metadata field called process date, so we can set up the action like this. Metadata is useful in other situations as well, such as assigning meaningful names to files being exchanged using FTP, or constructing the subject text for emails. This same action shows an example of the latter. On the Action tab, we're using a Send Transaction action, and the Communications method has been set to Email. This gives us an additional settings button where we can specify the recipient and the subject text to use. Notice that the subject text includes the expression meta:supplier code. When the email is sent, this causes the supplier ID to appear in the subject text.